The next chapter is 4.2 and this is about theoretical probability. Yesterday we did the two definitions of probabilities. The first one that we did yesterday is called the experimental probability. The experimental probability is the probability that we calculate when we actually do an experiment. That's what you actually see in front of you. So you did an experiment, and based on that you find this is the probability. The theoretical probability is the probability that's based on the chance. You don't do the experiment actually, you just think about it, and you will suppose that this will happen. It may happen, it may not happen, right? You're not doing the actual experiment. It's all based on what it's supposed to be, what it should be. It might not be the exact thing that will happen when you do the experiment, and in that case the probability will be called the experimental probability. The theoretical probability is that probability that's based on the chance. You're not doing the experiment, it's all based on what will happen, what should happen ideally, right? All the problems that we did yesterday, they were based on different experiments. That's why that probability was called the experimental probability. Now the problems that we will do today, we won't do any experiment. It's all based on the ideal conditions. That's what you will suppose that this will happen. For example, as I did that example yesterday, if you toss a coin, let's say you toss a coin, you know that there are 50% chances of landing heads and 50% chances of landing tails. So you will say the probability of heads is 50%, or you can say 0.5, and the probability of tails is the same, 50% and 0.5, right? But when you actually perform the experiment, then you might end up having, let us say you do 10 trials. 10 trials means you toss the coin 10 different times, and ideally, theoretically, we should have equal number of heads and tails. That means when you do this experiment 10 different times, it should land heads 5 times out of 10, and it should land tails 5 times. Only then the probability will be 50% each, right? But it might not happen. You never know. You might end up having 6 heads and just 4 tails. So what's the probability of having heads? 60%. And the probability of having tails is 40%. So this probability is the experimental probability. Experimental. You did the experiment and saw what happened. But this was theoretical probability, because that's based on chance. This is the ideal condition. You will suppose that this will land 50% times, this will also land 50% times. So experimental probability may not be same as the theoretical probability. All the problems that we did yesterday, they were based on experiments. So they were related to the experimental probability. Today the questions that we will do, that is based on theoretical probability. This will be the ideal condition, the chance, right? Okay, so let's look at the examples in this chapter. Look at the first example on page 154. This is page 154, example 1. If you draw a card at random from a standard deck of 52 playing cards, what's the probability that it will be one of the following cards? Part A is heart, part B a blackjack, and part C a card other than a diamond. Okay, you need to understand first of all what's there in the playing cards. You know that there are 52 cards in total. In the deck of playing cards, you have 52 cards. How many colors are there in the deck of playing cards? Two colors. Two colors. Okay. You have red and black. Then the red cards, they are further divided into two different types. What are they? What's this symbol called? Diamond, right? So diamond is red, right? What's the other one that's red?
Club.
Club.
Or heart.
Club or heart?
Heart.
Heart, okay. So that's red. They're both red, right? Okay, now the black one of them is, you said?
Club.
Club, okay. It looks like this, right? And what's the other one?
Spade. Spade.
Sorry?
Spade.
Spade, okay.
Yeah.
It's like
It's like
this.
an upside down heart.
Sorry?
It's like an upside down heart.
Yeah, but there is a little tail also like this.
It's like pointy.
Yeah, something like that.
Like a triangle.
Whatever, yeah, I'm not a perfect drawer. So these two are red, and this is called diamond. This is called heart. They're both red. And this is called, what was this? Stephanie, what's this called?
Club.
Club, okay. And this one is spade? Okay. And each of them is how many? Total number of cards is 52, and they are equal in number. So each type will be how many? 13, right? You have 13 cards of this type, 13 of this type, 13 this type, 13 this type. This will make total of 52 cards. That's how a deck of playing cards is arranged. You have two different colors, red and black, and then within red there are two types, diamond and heart. Each of them is 13 cards. Black, you have these two different types, they are called club and spade, and each of them is again 13 different cards. That's how the deck of playing cards is arranged. Now the question is, we are doing example number 1 on page 154. Jennifer?
Yeah.
Okay, if you read this question once again, it says, if you draw a card at random from a standard deck of 52 playing cards. So you have a deck of these playing cards, you got 52 cards, and you just pick up one card from these 52 cards. Just one, randomly. It can be any card. You can get a diamond, you can get a heart, a club or spade, and within diamond you got 13 different types of cards. So it can be any of these 52 cards that you are picking up at random, right? You have to find that the card that you draw, what's the probability that it will be a heart?
13 out of 52.
Yes, easy stuff. You got 13 cards that are heart. So what's the probability that the card that you draw is heart? That will be 13 out of 52. You got 13 heart cards and total number of cards is 52. So what's the probability of drawing a heart? 13 out of 52. How do you write it? Probability P of what? What do you write in the bracket? What's the name of your event? Heart. Yes. Probability of drawing a heart is equal to what? The total number within that event is 13 divided by the total number 52. So that's how you find the probability of drawing a heart. And then you have to write this in 4 different ways. If you can simplify this, you should. Can you simplify it? Is there any common factor? Why? You can divide both of them by 13, isn't it?
Oh, yeah.
13 divided by 13 is 1, and 52 divided by 13 is 4. So 13 out of 52 is same as 1 out of 4. And how will you write it in words? It's 1 out of 4. That's one way of writing the probability in words. But what's this number in decimal? When you divide it, what do you get?
0.2.
0.25. That's another way of writing the probability. Another way is multiply this by 100 and that will give you the percent, 25%. And then you have this one also, the fraction. So these are your 4 answers. The answer given in fraction, 1 over 4. Answer given in words, 1 out of 4. Same answer given in decimal, 0.25. And the same answer given in percent, 25%. So what is the probability that the card that you drew will be a heart? The probability is 1 out of 4, 0.25 or 25%. Did you actually perform this experiment? No, it's all based on the chance. This is the ideal condition. That's why it's called theoretical probability. It's not experimental. You're not doing that actual experiment. This is what you are thinking that it will happen if you do it. Okay, part B of the same question. Part B. Now you have to find the probability that the card that you drew, the randomly drawn card, what's the probability that it will be a black jack? The probability that the card that you're going to draw is a black jack. How many black jacks are there in the 52 cards?
2.
2, yes. First of all, you know that these 2 are black cards, 13 clubs and 13 spades. Clubs, they got 1 jack, and spades also got a jack. Each of them got a jack. This one also had a jack. This one got a jack. So there are 4 jacks in total, right? But you are going to find the probability of a black jack. Black, you got this black and this black. So there will be 2 black jacks, right? What's the probability that the card that you drew is a black jack? How many cards are there that are black jack? 2. And divided by the total number of cards, which is 52. So it's 2 out of 52. And then you simplify this, divide this by 2 by a common factor. This will give you 1 out of 26. So that's your answer, 1 divided by 26. But you need to report this answer in 4 different ways. So you can write this as 1 out of 26. Then you change this into decimal, divide 1 by 26, what do you get? Point 038. And then you multiply 0.038 by 100, that will be in percent. It will be 3.8%. These are your answers, 4 different answers. They are the same answers actually written in different forms. Right?
Medicine.
Yeah, after this.
Yeah.
Then part C. Probability that the randomly drawn card is other than a diamond. The probability that the card that you drew is not a diamond, other than diamond. How many cards are there that are not diamond? You have 13 cards that are diamond, right? How many are not diamond? 13 times 3, 39. So that will be 39 divided by 52. This is the probability that the randomly drawn card is not a diamond. 39 divided by 52. And then you can simplify it. You can divide this by 13, this by 13. This will give you 3 out of 4. So your answer will be 3 divided by 4. It can be 3 out of 4. It can be 0.75 or it can be 75%. All the answers are same. Right? It's just about thinking about the problem. It's not difficult. You just need to think about it and that's it. Okay, let's do the next problem. It's build your skills problem on next page 155. And in this question, you have a spinner. You can spin it and it will stop after some time. And the spinner has got different options on it.
Did you say 155?
Yep.
I don't got that page.
Oh yeah, I have to make a photocopy for you. I just did the previous chapter for you yesterday. I'll give you that after this one, right? The spinner has got different options. It has got, I will just draw them. Yes. So there are 10 different options. This one is a triangle. This is a star. I don't know how to draw it. How do you draw a star?
Go down.
Okay.
Now back up.
Here?
No other way, like, do you want me to do it?
Yeah.
Draw a triangle first, then draw an upside down triangle.
Okay, the first triangle should be a simple triangle like this.
Yeah,
And
and then
then-
do a backwards one.
Oh yeah, this is
There you
much
go.
better. Good. Excellent.
He's like, oh, remember this one.
Okay. Then you got a circle there. A heart. Okay, another star. Wow. So a triangle.
You have to do it at an angle now.
Yeah. No, I got it
There
now.
you go. Easy.
And then a square. Triangle. Star. Triangle and another triangle. Good. Circle. Heart. And that's it. And there is a little pointer over there. So it can stop anywhere when you rotate it. So this is a spinner, you're going to rotate it, and how many options are there? If you
10.
count them, there are 10 different options, right? Okay, you have to find what's the probability that the spinner will stop on a star. When you rotate it, what's the theoretical probability that the spinner is going to stop on a star?
3 out of 10.
This is how you write it, P of star, the probability of a star. How many stars are there? 3 out of 10. That is the probability that the spinner will stop on a star. 3 out of 10. You can't simplify it any further. There is no common factor in 3 and 10. But you have to write it in 4 different ways. That's your first answer. Then you write it as 3 out of 10. Then you write it as 0.3 when you divide this using your calculator. That will be 0.3. And then you multiply 0.3 with 100 and that will give you 30%. All the answers are same. This is just a different way to write them. You can say there are 3 out of 10 chances that the spinner will stop on a star. You can say 30% chances are there that the spinner will stop on a star. Right? They are the same things. Then part B of this question. What's the probability that the spinner will not stop on a heart? Probability of not a heart. What's the probability that the spinner will not stop on a heart? How many things are there that are not a heart?
8.
8? How many hearts are there? 2 hearts. That means 8 of them are non-hearts. So it will be 8 out of 10. It's not a heart. You got only 2 hearts, but the rest of them are non-hearts. The probability that the spinner will stop on a non-heart. 8 of them are non-hearts, and total of 10 things are there. 8 out of 10. Then you simplify it. You can divide both of them by 2. You will get 4 out of 5. So this is your first answer, 4 over 5. Then you can say 4 out of 5. Then you will divide this. You will get 0.8. And this is equal to 80%. All the answers are the same. Part C. What's the probability that the spinner will stop on a square or a triangle? The probability that the spinner will stop on a square or triangle. How will you find this? Square or triangle? Both of them together.
By adding them together?
Yes, square and triangle will be added. How many squares are there?
1.
Just 1. And how many triangles?
2.
2. So 2 plus 1 divided by 10. It's 3 out of 10. Right? 3 out of 10. Which is equal to 3 out of 10, or it's equal to 0.3, or it's equal to 30%. Is it difficult? It's pretty easy, right? Just need to think about it. Okay, let's do another one. Question 2. A standard 6-sided die is tossed. Is it dice or die?
Yeah, it does.
Dice? Dice or die?
Yeah.
But some people call it dice.
Yeah. Maybe that's the
I think you call it
difference
single
between
base
those.
day.
Sorry?
I think you call it single base day.
One is a die. Yeah, that's, yeah.
Oh, yeah, so
Okay.
singles.
One is
So
a
dice is
die.
a plural?
Dice is more.
Oh, okay. So if you had 2 dice, then it will be dice.
Yeah.
It's with a C, not with an S.
Yeah.
Okay. A standard 6-sided die is tossed. What's the probability that it will land on 5? So you know that a die looks like this. I drew the picture yesterday also. So it looks like this. It has 6 faces and you got little dots. 1, 2, then 3, and then the remaining 3 sides will have 4, 5 and 6 on them, right? And because it has 6 faces, all the faces have equal chances. When you roll it, what will be at the top? All the faces got the same chances, right? And you have to find the probability that it will land on a 5. The probability that it will land on 5 dots. You will have 5 dots face at the top. How many 5 dot faces are there? Just one face, right? And how many total number of faces are there? 6. It's 1 divided by 6. That is the probability that it will land like this. It will have 5 dots at the top. This can be 1, whatever. All the faces got the same probability, 1 out of 6. Then you can convert this number into words and decimal and percent. You can do that on your own. What's the probability that it will land with an even number at the top?
3 and 6.
Yes, there is a 1 dot, then there are 2 dots, then there are 3 dots, then there are 4 dots, 5 dots, and 6 dots. You know that this is odd, this is even, this is odd, this is even, this is odd, this is even. How many even faces are there? 1, 2, and 3. The probability that it has an even number at the top, you got 3 faces with even numbers. And how many total number of faces are there? 6. 3 out of 6 is same as, if you divide both of them by 3, you get 1 out of 2. 50% chances. The probability that it will land on a multiple of 3. A multiple of 3. Now out of these 6 faces, how many are multiple of 3? This is a multiple of 3. Multiple means if you multiply 3 with 1, if you multiply 3 with 2, with 3, these are called the multiples of 3. So 3, 6, 9, 12, they are multiples of 3. So 3 is a multiple, 6 is a multiple. You got 2 numbers in these 6 faces that are a multiple of 3, right? So what will be the probability? 2 out of 6. There are 2 numbers. This is a multiple of 3 because it's 3 dots. This is also a multiple of 3 because it's 6 dots.
And first one, old.
This one?
Yes.
1 is not a multiple of 3 because you cannot multiply 3 with any number to get a 1. You're looking at these numbers. This is a multiple of 3. This is a multiple of 3. 9 is a multiple of 3. 1 is not a multiple of 3 because what number will you multiply with 3 to get 1? None. It will be a decimal number, right? It will be 1 over 3. If you multiply, this will give you 1. But we are just looking at the integers, not the fractions. 1 is not a multiple of 3.
That's the assignment?
Okay? So it's 2 out of 6, and then you divide both of them by 2. This will give you 1 over 3. So 1 out of 3 is the probability that it will land on a number that is multiple of 3.
Just here.
I want you to do the next one on your own. Question number 3 on page 156. Question 3 on page 156. This is what you will do on your own. And you can finish it in 2 minutes.